Welcome to another video on differentiation. This is again a marathon series where will solve a range of questions. Let's start with question number one. It says the function f is defined for f of x equals to 1 over x plus 1 plus 1 over x plus 1 whole square. For x is greater than minus 1, find f bar of x. So what I will have to do is first bring everything to the numerator so that I can differentiate it. Then in order to differentiate this, I'll bring the power down, subtract 1, and multiply by what is inside the bracket, the differentiation of what is inside the bracket. Then I will bring another power down and then multiply by 1. So that is f bar of x. Even if I leave it like that, that's absolutely fine. It says state with the reason whether f is an increasing function, a decreasing function, or neither. So what I can conclude from here is that when I observe f bar of x, the first term is negative, because although there is a square over it, if I were to simplify this, this would look something like this. Okay. And power 3. Okay. Since x is greater than minus 1, so x largely takes on value. This bracket is positive and there's a negative sign outside. So with the reason, I'm going to say that all terms are negative. Therefore, f bar of x is negative, and the function is always decreasing. Okay, and then it says the function g is defined by g of x equals to 1 over x plus 1 plus 1 over x plus 1 whole square for x is less than minus 1. That was for greater than minus 1. This one is less than minus 1. Find the coordinates of the stationary points on the curve g of x. So I simply need to take the previous answer and equate it to 0. I will have to be wise with my calculations, otherwise it's going to become a very long question since I see something cubic in it as well. So what I'm going to do is I'm going to first take this to the other side and say that this becomes x plus 1 cube equals to minus 1 over x plus 1 whole square. Notice that I'm not going to cancel out right now because I know that something's going to turn out common. And once I take that common, I will be able to figure out some roots. So what I'm going to do is I'm going to take x plus 1 whole square common. So I'm left with 2 plus x plus 1. So either this equals to 0 or that equals to 0. That becomes x plus 3 equals to 0, x is equals to minus 3. From here I get x plus 1 equals to 0, x is equals to minus 1. I'm going to take that because it says x is less than minus 1. So I have minus 3. Can I find out the y coordinate? Yes, I can find out the y coordinate. I have the initial function. I'm going to take my x value and use it there. Okay, so 1 over 4 minus half should give me minus half. Minus 3 comma minus half is my stationary point. Moving on to the next question. I think that was 3 parts. Okay, moving on to the next question. I have question number 2. It says the diagram shows the curve y equals to 2x squared and the point x is minus 2 comma 0 and p comma 0 is this. The point q lies on the curve and pq is parallel to the y-axis. Express the area A of the triangle xpq. So I'm looking at this triangle. Area of a triangle, of a right triangle, is basically half into base into height. So I'm going to say half base. So this distance is p and this distance is 2. So I'm going to say that the base is p plus 2. I would have also said p minus minus 2. That's how you would calculate the distance. And then the height. Now, this is an interesting part. Um, the point Q lies on the curve PQ. So can I say that the x coordinate of Q will be the same as P? So it's going to be P comma something. I don't know, P comma Y, let's call that. Um, so I am going to say that the height of this triangle is basically Y. But I don't need the area in terms of Y, I need the area in terms of P. So what I can do is I can plug in this coordinate into this curve and say that Y is Y, X is P, so Y should be 2P squared. So I'm going to say half P plus 2 into 2P squared. Cancel out the 2's and say that this becomes P cube plus 2P squared. So area is P cube plus 2P squared. Then it says the point P moves along the x-axis at a constant rate of 0.02 units per second. So this point is traveling. So it's not traveling along y, it's just traveling along the x-axis. So can I say that it's basically dx over dt? In essence, since it was named p, can I say that dp over dt? Remember that whenever I say at a constant rate, I'm talking about a rate of change, 0.02. And q moves along the curve so that pq remains parallel to the y-axis. Now remember that when q is moving, of course, it's causing the x coordinate to change as well and the y coordinate to change as well. So I can't really summarize q right now. Let's see what it says. Find the rate at which a is increasing. So the only thing that's happening is that when q moves, it stays as a right triangle. So the area will sort of remain as this function. Why? Because P and Q will still have the same x coordinates. So find the rate at which area is increasing. So I'm asking you for dA over dt. Now remember that whenever you have a differentiation question, your objective is to differentiate. This is the expression that I have that connects A and P together. So let's differentiate this. When I differentiate this, I get dA over dP, which becomes 4P plus 3P squared. Now, we've done in class that you can decompose this differential into a chain rule. So dA over dP becomes dA over dt divided by dP over dt. That is how I construct the chain rule. If in case you do it differently, that's absolutely fine as long as you do it correctly. So dA over dP is 4P plus 3P squared. dA over dt is something that I'm trying to find. And dP over dt was 0.02. So I'm asking you when p equals to 2. So 4 times 2 plus 3 times 2 squared. So what do I get from here? 8 plus 12, 20. So I get 0.4. Okay, moving on to the next question there. It says a wire of length 24 is bent to form the perimeter of a sector of a circle. So the sector looks something like this. We've done this in circular measure. I hope you've watched other videos for the topic. So that's a sector. Now remember that when I say a wire is bent, so I'm talking about the entire perimeter of that sector. So which consists of what? It consists of two arc lengths, two radii basically, and one arc length. In case you don't remember the formula for the arc length, it's r theta. So show that the area of the sector. Okay, so area of the sector, we've done this formula before. It goes like half r square theta. That doesn't match what's there in the question. This theta that's there in our solution. How do I get rid of theta? I'm going to use this 24 that's there. I'm going to say that 24 was made up of r plus r theta. So 2r plus r theta equals to 24. So 24 minus 2r equals to r theta. Now theta equals to 24 minus 2r over r. Okay, so I have a relationship between theta and r. So I'm going to use that and say that half r squared into 24 minus 2r over r. I get 24r minus 2r squared divided by 2. If I separate the 2 for both, so 24 by 2 becomes 12r, and 2r squared divided by 2 becomes r squared. So I have the same answer that the question was asking for. So part 2 says express A in the form A minus R minus B whole square. So this is more of a completing the square question. Let's do that quickly. So we are going to use 12R minus R square equals to A minus R minus B whole square. Okay. And then I'm going to say that I'm going to do a comparison here and say that this is A minus r square minus 2br plus b squared. So A minus r squared plus 2br minus b squared. So I have minus r squared plus 2br plus A minus b whole square. I'm going to then do a comparison. I'm going to say that 12 should equal to b. And since this is the same as that, minus 1 and minus 1 match, I can't do much about it. So 2 is b is basically 6, but I can see that there are some constants on the right hand side which are not there on the left hand side. So I'm going to say that these should equal 0. So a minus b squared should equal 0. A minus 6 squared should equal 0. A is equals to 36. So I've expressed this in the completed square form, 36 minus r minus 6 whole square. This is area equals to 36 minus r minus 6 whole square. Once I have that, it says given that r can vary, so the question is asking me to differentiate, state the greatest value. Now when it says state, that automatically means that the answer should be there in front of me rather than calculating something. I'm just going to figure out what the answer is directly and tell you that in this case I can see that the turning point is 6 comma 36, like we learned in completing the square. Okay, so what is the if the turning point is 36, then the greatest value of A should also be 36, and this is R and this is A. Okay, so the greatest value of A is 36, corresponding R is 6, and but it says corresponding angle of the sector. Okay, corresponding R is 6, so if I have R, I can figure out the angle, right? I have the expression for theta here. 2 times 6 over 6. So that gives me 24 minus 12 over 6, which is 2. So when theta equals to 2, now this may sound odd to you, but this is in radians, therefore it's not 2 degrees. It's not a very small sector. It's a reasonably sized sector. Okay, moving on to the next question. This looks like a rate of change question that I earlier did, but let's see what's happening. I don't know for sure. The equation of a curve is y equals to this, where p is a positive constant, so that the origin is a stationary point. Okay, on the curve, and find the coordinates of the other stationary point in terms of p. So basically I'm trying to find out stationary points. So I'm going to say that y equals to x cubed plus px squared dy over dx, 3x squared plus 2px. Now find the other coordinates in terms of p. So I'm going to say that I have to equate this to 0. I take an x common, 3x plus 2p. So either x equals to 0 or 3x plus 2p equals to 0. 3x equals to minus 2p. X equals to minus 2p over 3. That's part 1. Part 2 says, part 1, okay, origin is the stationary point, so y is also then relevant, because I want to prove to you that the origin is the stationary point. So 0 comma 0 is the origin and it is part of the stationary point, so I've proved to you. Find the coordinates of the other stationary point in terms of p. So I found the x coordinate. I still need to find the y coordinate. I'm going to say that the y coordinate is simply plugging in the value of x. So y equals to minus 2p over 3 I think there's a typo here. It should be 3. Cubed plus p into minus 2p over 3 squared. Or maybe that's the minimum. Oh, fine. Okay. Um, Minus 8p cube over 27 plus p 4p squared over 9 minus 8p cube over 27 plus 4p cube over 9 27 plus 12p cube. Okay, so that's the y coordinate, and I think that's the right one. Um, then it says part 2, find the nature of each of the stationary points. So I'm going to double differentiate first and then plug in those stationary points that I have. So double differentiating first, 6x plus 2p d square y over dx square at x equals to 0. So 6 times 0 plus 2p, that gives me 2p. Since p is a positive constant, this is positive, therefore minimum. Okay. Then d square y over dx square at x equals to minus 2p over 3. So 6 times minus 2p over 3 plus 2p. So that gives me minus 2p. Negative, therefore maximum. Okay, so part 3 says find the set of another curve has the equation. So this curve has changed. So dy by dx should also change. Find the set of values of p for which this curve has no stationary point. So y equals to x cubed plus px squared plus px. Now, when it says it has no stationary points, the first thing that I should do is I should differentiate this 3x squared plus 2px plus p. Now, if this equation is not supposed to have any roots of x, basically this equation, when I equate this to 0, what I can say is that this is a quadratic with no real roots. Now, when it has no real roots, what I can then go on and say is that it's b squared minus 4ac should be less than 0. So a is 3, b is 2p, and c is p. So b squared minus 4ac should be less than 0. So 4p squared minus 12p should be less than 0. This is the normal quadratic inequality that you would solve. You would say that I will have two roots. When I solve this on my calculator, it's going to give me two values of p. P is 0 and p is 3. That's what I've done on my calculator. Or if you want to solve them manually, it's also up to you. You will solve this equation manually and say that you can factor out a 4p and then sort of take a common and then solve. You get two values, 0 and 3. What values am I looking for? I'm looking for values that are less than 0, so I'm looking at this part of the curve. So what values do I see? P is between 0 and 3. This is a p-axis. It's not your x-axis. This is your p-axis because you're getting values for p. Okay, so p is between 0 and 3. So when p is between 0 and 3, this new curve will have no stationary points. Interesting that way. Okay, then let's look at question number 5. It says the horizontal base of a solid prism is an equilateral triangle of side x. So I'm going to draw that equilateral triangle on the side. It's a prism. It should look something like this. Okay, just to show you what it looks like. It has a side of x. And since it's equilateral, I'm going to mention 60 degrees as well. The sides of the prism are vertical. Okay. This prism is actually placed in a different way. Let's draw it in a different way. It's not placed like that. It's placed like that. drawn a really bad prism here. Okay, so I can zoom in and erase some lines and you can see it better. Okay. So that is what my prism looks like. From the top, it should be an equilateral triangle. Okay. Okay. Then the height of the prism is h, and the volume of the prism is 2000. So volume is 2000. Express h in terms of x. So I just have volume to do that and show that that's the second part. I have to show you the surface area. So first I'm going to work with the volume. The volume of a prism is area of cross section into its height or length, whatever may be relevant. So in this case, I'm writing down length. In this case, I'm writing down height because it's placed vertically like that. So volume is 2000. What is the area of the cross section? This is this triangular cross section. Now, this is a triangle with equilateral, it's an equilateral triangle with 60-degree angles. So I'm going to use the formula half AB into sine of C, and C is 60 degrees, and that's height. So I'm going to say that this becomes 4000 x squared sine 60 is root 3 over 2 h. So I'm going to say that h can then be written as 8000 over root 3 x squared. I think that makes sense. Root 3x squared should be in the denominator. Yes, express h in terms of x and show that the total surface area. So I'm going to work with the total surface area now. Area of a surface area of a prism is perimeter of cross section into height plus 2 times area of cross section. Okay, so area equals to the perimeter should be x plus x plus x, that's 3x into h plus 2 times area of cross section. So that was half x squared into root 3 over 2. Yeah, so I get 3xh plus x square root 3 over 2. I didn't want h, I wanted something in x only, so I'm going to plug that in here and say that this is 8 over, okay, plus x squared root 3 over 2. I'm then going to evaluate this on my calculator and say that I can get 3 into 8000 divided by root 3. Okay, I think I will have to, no, it's given as a root 3 in the denominator. Otherwise, I would have rationalized this myself. 24,000 over root 3. And you can see that in the proof. It's x in the proof. So x squared into root 3 over 2. So area is 24,000 x power minus 1 over root 3 plus x squared root 3 over 2. Okay, that's area. Then in part 2 it says given that x can vary, so I'm going to differentiate this and I'm going to say that dA over dx is minus 24,000 x power minus 2 over root 3. Okay, I've differentiated the power plus 2x root 3 over 2. So that's the differentiation. Then I need to equate this to 0 because I want to find the stationary value, find the value of x for which it has a stationary points. So I'm going to bring that down. It's x root 3. I'm going to shuffle around things. I'm going to bring this here and try to solve. So cross multiplying this gives me 3x cubed equals to 24,000. X cubed equals to 8,000 and the root of 8,000 then. I think I made a small error. Let's try figuring that out. 2 root 3x minus 24,000 over root 3x squared Find the value of x. So this should be about 8,000. Yeah, I think I'm getting it correct. X equals to cube root of 8,000. That gives me 20. Yeah, and there was a square root with square. Got me a little confused. Determining showing all your work necessary the nature of the stationary values. I'm going to pick up dA by dx again and now start differentiating. So minus 24,000 x power minus 2 over root 3 plus x root 3. So differentiating this again gives me 48,000 x power minus 3 over root 3 plus root 3. That's double differentiation. I'm going to plug in the value of x and say that this gives me a positive number, positive, therefore minimum. Okay, that is part 3. Yep. Okay, that's the entire question then. Let's look at the next one. It says a point is moving along the curve y equals to 2x plus 5 over x in such a way that the x coordinate is increasing at a constant rate of dx. So that's dx over dt. I've immediately pointed that out to you. And the rate of change of the y coordinate. So I'm asking you for dy by dt. So this is a question on rate of change. Remember that this is a differentiation question again, so you need to differentiate. You get dy by dx equals to 2 minus 5x power minus 2. Okay. Then you've learned the chain rule, so you start decomposing it. So dy by dx can be decomposed into dy by dt divided by dx by dt. So dy by dx is 2 minus 5x power minus 2. dy by dt is the unknown here in this question, and I have 0.02. So 2 minus 5 times 1, minus 2 into 0.02 equals to dy by dt. So dy by dt 2 minus 1 over 5. That gives me, when x equals to 1, yeah, okay, so 0.06 minus 0.06. That's what I have from my calculator as well. So I have dy by dt is equals to minus 0.06. Move on to the next question. It says the tangent to the curve. Okay, so that looks like differentiation for tangents. At a point A is parallel to the line y equals to 2 minus 3x. So the gradient of this line seems like it's minus 3. Find the equation of the tangent at A. Okay, so I know that the gradient, if this is parallel, then the gradients should be equal. So my dy by dx, which is 3x square minus 18x plus 24 minus 0, should equal minus 3, because that is what I wanted to be parallel to. Okay, so 3x square minus 18x plus 24 plus 3, 3x square minus 18x plus 27. So that's what I'm trying to solve. I think it's going to give me just one value. That's 3. Let's just verify quickly. Yeah, 3. So x equals to 3. So the x coordinate is 3. It's asking me to find the equation of the tangent, which means that I have the gradient. And I want to do this y minus y1 mx minus x1. Why did I do the differentiation part? Because I would have, I wanted to know what the x coordinate was. I wouldn't have formulated an equation without that. So I have x minus 3. Do I have y1? No, but I can still figure out what y1 is by using this here. Okay, so 27 minus 81 plus 72 minus 12. 6. So y minus 6. And simplify this. Plus 15. Okay. The function f is defined by this for x is greater than k, where k is a constant. find the smallest value of k for which for f to be an increasing function. Okay, so I want dy by dx should be greater than 0. That's what increasing functions are. So let's put that in here. 3x squared minus 18x plus 24. So basically solving a quadratic inequality. So when I solve this quadratic equation, again on my calculator, 3 minus 18, 24. So I get 4 and 2. So I get two coordinates, 4 and 2. I'm going to say that if I want greater than 0, I'm going to highlight this part of the curve. And I'm going to say that either x is less than 2 or x is greater than 4. What value was I trying to match? I was trying to match this. So I'm going to match that and say that the smallest value of k is 4. So greater than 4 should give you an increasing function. Moving on to the next question. This looks very similar to a question that we did earlier. Um, yeah, okay. So it says find the point P is that lies on the curve that and the point P lies on the curve this. Find the x-coordinate of the point where the normal to the curve at P intersects the x-axis. So y equals to x minus 1 power minus 1 minus 9x minus 5 power minus 1. Okay, find the x-coordinate of the P where the normal to the curve at P. So I'm looking for the normal at P. So I'm going to first differentiate and say that I know that this is a differentiation question. Some marks are there for just differentiating correctly. So you do 1 plus 9x minus 5 power minus 2 into 1 again. Then I'm going to plug in x equals to 3 because that's the x-coordinate of P. And I'm going to say that 3 minus 1 power minus 2 plus 9, 3 minus 5 power minus 2. What does that give me? I'll just use my calculator quickly and tell you that this is minus 1 into 2 power minus 2 plus 9 minus 2 power minus 2. That gives me 2. So that's gradient of tangent, gradient of normal should be minus half. So y minus y1 mx minus x1 2y minus 10 minus x plus 3 2y equals to minus x plus 13. Okay, where the normal to the curve at P intersects the x-axis. Now for intersects the x-axis I have 0. I'm just wondering if there's a mistake in the signs. Looks fine to me so far. So 1 over 8 plus 9 over 8 over 8. Just checking if my calculations are correct. Okay, no, yeah, that's fine. So x equals to 13. I didn't notice the negative sign. Okay. Uh, then it says find the x coordinate of each of the stationary points on the curve and determine that. Okay, so I'm going to pick it up from here for part 2. Uh, 9x minus 1. So this looks like a longer question than I expected this to be. So I have 8x squared minus 8x plus 9 minus 25 should give me minus 16, I think. Yeah. Let's try solving this on a calculator. 8 minus 8 minus 16. 2 minus 1. Yeah, sounds right. And I have to justify whether they are maximum or minimums. So I start with dy by dx again. Very long question, but very simple one as well. So I'm happy doing these questions. D square y over dx square equals to 2x minus 1 power minus 3 into 1 minus 18 x minus 5 power minus 3 into 1. So d square y over dx square at x equals to 2 first. 2 minus 1 minus 3 minus 18 2 minus 5 power minus 3. Put that on a calculator. First number is 2, so I'm not really going to put that on my calculator. Next one is a negative power and everything, so I'm going to put that. It's 17 over 4. So x equals to 2 is a minimum, and x equals to minus 1 is a maximum. Therefore, this was positive. The other will definitely be negative. Okay, justifying your answer. If it says justifying your answer, then you should do this. Minus 5. Okay, so this will turn out to be a negative number. Okay, that brings us to the end of this worksheet. I will see you with now integration questions. I've completed all the differentiation marathons that I wanted to. I will see you in the next video. Make sure to like and subscribe if you're watching, and tell me in the comments if you want more videos like this. Thank you.